This final lesson of Chapter 10 is another way in which to organize data. We call it a box and whisker plot. And the purpose of this is actually to see how data is distributed. And if you create a couple of these based on similar data, again, we can use it for comparison, which we'll see at the end. So one of the most important parts of a box and whisker is the idea that the box and whisker is going to divide the data into 4 groups. Now, to accomplish this, one of the first tasks, which might be the most time consuming, is to put the data in order. Once it's in order, you're going to divide it first into an upper and lower half. By finding the median. Then you're going to take the lower half and find its median. We call that the lower quartile, with the prefix quart meaning 4, kind of like a quartic, which is a 4th degree polynomial. Now, if you would like, when you're doing this in your homework and stuff, if you just want to go LQ, that's totally fine, because writing out lower quartile can be kind of a little tedious. All right. We're also going to find the median of our upper half, and then we're going to call that our upper quartile. Now, as a heads up, this is the language that they use in this particular book. There are other books, and you probably will see this in the future, where the lower and upper quartile are actually denoted as the first and third quartile, because again, it's 4 parts. The second quartile is the median. So just be aware. This particular book refers to it as LQ, UQ, but you may see it here in the future listed as first and third. All right. So first, order the data. So the following is the lengths of songs on a CD, and we would like to make a box and whisker pot of the song lengths. So our first data, smallest one here, is 173. And I'm going to cross them off as I go here. The next smallest should be 179, followed by 181, then we have 198, and then 206, followed by 239 and 246, then 251, 257, 261, and then 295. So cross them out as you go. Make sure you didn't miss one, because your whole box whisker plot will be slightly skewed if you forget a point. Okay, so let's review how we find the median, because that's what we're going to kind of look at first. How do we find our median? So if it's in order, it should be the one in the direct middle. If there's an odd number, then there should be one number there. If it's even, you'll average the 2 middles. So if we count this out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we do have an odd number, and I believe your median ends up being 239. So the median is 239. Now we'll plot that here in a second. I'm just going to go ahead and calculate them all first. Now keep in mind that's the median of the whole data set. Now, since there's an odd number, that means you can't technically divide this in half. So when there is an odd number, you actually leave this median out of the upper and lower half. So now this side is now our lower half. and this side is our upper half. So next step is to find the quartiles. So LQ is our median of the lower half, and UQ will be the median of the upper half. So I believe of these 5 numbers, our middle should be the 181. And of these 5 numbers, it should be the 257. Now, to get the last piece of this so that we can completely break our data into 4 parts, is to state our minimum and maximum values. So in other words, what's the biggest number? What's the smallest number? So the max in this particular case, I believe, is 295. And our minimum is 173. Now, somewhere on your homework, as you're doing these, and if you were taking a test that was by hand, you would want these values listed, or you would list them next to the edges. So you'll see down here, this is their minimum. This is the lower quartile, median, upper quartile, maximum. They've got them labeled right next to it because it's not obvious that what all those decimals are. So here in a second, we're going to pick a scale to count by on our number line. And you want to make sure that you either have these listed somewhere or you list it next to your pieces of the box and whisker. All right, so let's pick out a scale or an interval to count by on our number line. Our smallest is 173 and our biggest is 295. So if we kind of go to the nearest 0 or 5, we'll go like 170 to 300, or we could go 295. Depends on what we want to count by. To get all the way up to the 290s, we probably need to count by tens. So maybe we'll go 170 to 300. Now, it's not necessary for you to label each one. If you really want to, you can. You need to have at least, if when you're drawing these by hand, have at least 2 marked so that someone reading your graph would know what you're counting by. And you want to make sure you pick a scale that allows your data to kind of breathe a little bit. Let me kind of scooch these down just a little. Because if you put your data values too close together, it's going to make your box and whiskers so smushed you can't actually analyze what's happening. So you want to make sure you pick a good interval so that, I gotta space these out a little bit better here. But you want to pick a good interval so that you can read your data. Okay, I think those kind of look even. So if we keep labeling here, this should be 200. 210, 220, maybe I skip one just to kind of be 40, 50, 60, 70, 80, 90, 300. So I went a little too more tick marks than I need, but it's okay. All right, so first, we're going to plot some points. So I'm going to plot our median first, which is at 239. So if that's 240, I'm going to say 239 is somewhere in here, and I'm going to put a nice big dot. Probably needs to scoot over just a little bit. But this is why I have it listed. So if you want to write 239 right next to that, you can. You can also put it right on top of the number line. I prefer to do mine above or below. It's kind of up to you. It can go either way. All right, now I'm going to draw our upper and lower quartiles. So it is at 181 and 257. Now, what you're going to do in your box and whisker is you're going to draw the box portion to represent the center of this data. So about from the 25% to the 75% mark. So half of the data is going to be in the box, but it's the middle of the data, which you hope is kind of going to be the most valuable as far as figuring out where your data lays. So the box portion of a box and whisker goes from the lower quartile to the upper quartile. And then you put a line right through the median. So notice the median does not have to be in the middle of the box. If it is, good for it, but it doesn't have to be. So don't think you've done something wrong if it's not. And so that's kind of the second fourth and the third fourth of your data, since it's broken into 4 parts, from the left to the median and the median to the right of the box. So the last piece is representing the first fourth and the final fourth of our data, take us out to the minimum and the maximum. So our minimum was at purple, right? I think was at 173, and our maximum was at 295. And then this is where your whisker part comes in. So you draw little whiskers from the edge of the box out to your data value. And that is a box and whisker plot. So as a heads up, 25% of the data lands in here, which is a very small chunk, but that represents a fourth of the data. The next fourth lands in here, which is obviously way more spread out. The spread of the third fourth is a little smaller, and the spread of the bigger fourth is a little bit bigger. The beauty of this is, however, is you can say, all right, the center of the data, or the bulk of this data, and I should say bulk, half of this data is in the box. Does it tend to be toward the left side, or our minimum, toward the right side, which is our maximum? Does it kind of fall right in the center? And you can kind of tell how dense one section of your data is, and you can tell if you have outliers. So there's a lot that can be obtained from dividing up your data in this way. So let's practice some of that. And you'll see this on the worksheet portion of your homework. So the following represents the rainfall, the normal rainfall precipitation each month in Dallas and in Houston, Texas. Then they divvied it up. So this represents 12 months. It's for a year. And then they divvied it up into a box and whisker. So I want to know, for how many months is Houston's precipitation less than 3.5? So if we look at where 3.5 lands for Houston, that means it's this first portion. So each part of a box and whisker is 25% of the data. If this represented a whole year or 12 months, then we want to know how many months represents 25%. And that would be 3. So for 3 months out of the year, the rainfall was less than 3.5 inches. So always remember that each chunk represents 25%. All right, we want to compare the precipitation in Dallas with the precipitation in Houston. So you'll notice their maximums are actually kind of close. They're not too far off. But if you had to guess which of these cities has more rain as a whole, and I think you could guess that that would be Houston. Just based on the fact that their entire data, so all 12 months worth of data, if you kind of compare where it falls in the other data set, it is on the higher end. So they definitely gain more rain, precipitation as a whole. All right, so what I talked about earlier, just a little bit ago, was outliers. An outlier means that you have a number that kind of skews your data because it is way bigger or way smaller than the rest of the data. So sometimes when you get really large chunks of your max and your min, because our outliers are going to be on the outside edges, you'll notice that there's an outlier. So if you had to guess there was an outlier, which number would it be? In this particular case, this is 5.2. So this gigantic area here is part of what makes that it, but it's also the fact that this box here, all of these are kind of relatively the same distance. They're close. And then you have this gigantic gap. So that's kind of a clue in that there appears to be an outlier. And in that particular case, it is for Dallas. Because that 3-month span from 3.2 to 5.2 represents only 3 data values. So that's a pretty big gap from one